Hello everyone. So my name is Antonis Michalas, and I'm working as an assistant professor at Tampere University in Finland, where I also co-lead the Network and Information Security Group. So today I'm going to present a paper with the title "Charlie and the Crypto Factory." Obviously, the title is inspired by the popular book Charlie and the Chocolate Factory. So Charlie and the Crypto Factory towards secure and trusted manufacturing environments. The paper is co-authored with Professor Thomas Kish, who is the Director of Research Center for Parallel Computing at the University of Westminster in London, UK. Just a very few things about my background, since this conference will be held fully online and we will not have the chance to chat physically. So basically my research has been mainly focusing on applied cryptography and on provable security, which means that what I'm doing is basically designing secure and privacy-preserving communication protocols for widely deployed communication networks. Lately, I have been focusing a lot on protocols that can be applied to cloud computing, and I'm looking on problems related to cloud storage security, how to build cryptographic storage, and how to prove that it's secure, and also how to make sure that the design solutions are applicable, which means kind of efficient. Right, so our contribution for this paper. So first of all, we are going to try to collect the security requirements that we need to consider when building smart factories. So in this paper, we are not presenting a concrete solution, right? So instead of that, we are presenting a forward-looking design of a layered-based architecture that can support the design of secure and privacy-preserving smart factories. Apart from that, we hope that with this work and with presenting this forward-looking architecture, we will help protocol designers to build novel security protocols that can squarely fit the specific needs of smart factories and the latest revolution or the upcoming revolution of Industry 4.0. Good. So Charlie and the Crypto Factory. So as I said, we have a layered-based architecture. So let me briefly present the main layers. So first of all, we have the Edge multi-cloud layer, which, as you can imagine, is just a cloud platform where it will be used to store our data and make sure that we will have certain control panels that will allow us to manage all of the entities that will be part of this crypto factory. Apart from that, we'll have the secure execution layer, which will be special components, let's say, that will be occupied with special trusted hardware. And this hardware will allow us to run certain computations on a secure and isolated environment. Then we'll have the crypto library layer, which will be a collection of cryptographic libraries that will allow us to, create APIs and functionalities that will secure all of our assets in a modern factory. This will be, for example, the collection of data as well as the storing of data, but also in many cases the analysis and exchange of information. In addition to that, we want to have a layer where anomaly detection will be performed. So because there is a lot of information that is going back and forth on this exchange, lots of messages are exchanged between different components in the factory, we need to make sure that we have a mechanism that will be analyzing the traffic of our networks, and every time that something is they find something suspicious, then certain alerts they need to be raised to the administrators. And finally, we will have the analytics layer, where we will be basically processing the collected data and all the information that is exchanged or generated in the factory, and try to basically understand the needs or any kind of issues, or try to predict the future, let's say, like predict the needs that the factory might have in the very near future, right? Good. So let's see all these layers one by one. So first of all, we have the Edge multi-cloud layer. So basically, this will be the base of CryptoFactory architecture and will utilize cloud resources and also incorporate a wide range of IoT edge devices with main aim to collect and process data. So imagine that we will have many edge devices, IoT devices that are connected to the network, and they operate and they do very specific things in a smart factory. So these devices, they will be communicating directly to the cloud and or indirectly, and it doesn't really matter now. And they will be storing data to the cloud, right? So this layer, the multi-cloud layer, will have to build all the communication channels that will allow these devices to send and receive data from the cloud. In addition to that, the multi-cloud layer will also have to have an orchestrator as well as a certain platform, a specific platform that will allow the launch and management of all these devices. Now, apart from that, we'll have the secure execution layer. So the aim of this layer is to support the implementation of pluggable applications to enhance the security functionality of the CryptoFactory architecture. Now, in CryptoFactory, the cloud platform basically and the compute hosts that will be offered by the multi-cloud layer will be equipped with trusted computing hardware and firmware security features that support the creation of trusted and isolated execution environments. Some of the trusted computing devices, such as TPM, have been available even prior to the emergence of cloud computing. However, they are ill adapted to the cloud computing context and they have not been widely used. So a new generation of hardware and firmware security features such as the second generation of TPM or Intel SGX or ARM Trust Zone and so on have recently become available on cloud server applications and platforms. So unfortunately, cloud service providers provide at best only very limited access to such security enablers in their commercial offerings. So in CryptoFactory, this layer should apply the advances of trusted computing to enable basically cloud users to assess platform and software trustworthiness, as well as to deploy software in isolated execution environments. This will ensure the confidentiality and integrity of the loaded code and data. And to do so, hardware and firmware security features will be leveraged to develop applications for isolated execution environments that will support core functionality of a factory. In particular, such secure isolated execution environments will host support functions for attesting the integrity of edge devices as well as of the launched VMs in the underlying cloud environment. And that's what I'm trying to basically showing this figure, that we will have an administrator that will attest the trustworthiness or the integrity of the CSP as well as the edge devices based on some attestation protocols that we will build and will be based on trusted hardware. Good. So then we have the crypto layer. So in crypto layer, imagine that we have edge devices. Okay, what they have to do is that they need to start communicating with each other as well as with the cloud. And in order to communicate with each other, it will be good if they are able to exchange a key securely, a cryptographic key. And by using this cryptographic key, they will manage to encrypt and integrity protect all of their messages. So we will have to build libraries, lightweight libraries, in order to run on small devices, on constrained devices that will allow the secure and privacy preserving communication of devices that belong in the factory. So we will have we will achieve confidentiality and integrity. Apart from that, we have the factory that should be able to communicate directly with the cloud and send data to store in the cloud. Now, storing the data in the cloud means that we store our data in a remote location. In other words, in a location that we don't own. Therefore, it's of paramount importance that this data will be always stored in an encrypted form, and it will be even better if the encrypted form, if this data is encrypted with a key that is not known to the CSP. Therefore, keeping the confidentiality of their data even if the CSP gets compromised. Now, imagine that, okay, we have sent this data to the cloud, the CSP has stored the encrypted data directly on a local database, and then we should be able to process our data, which means that the CSP or an authorized user asks the CSP to get access to this encrypted data, and without even decrypting them or partially decrypting them, this authorized user should be able to decrypt this data, process this data, and send the output back to the factory or to any other authorized user, right? So with the crypto layer, we hope that basically the crypto layer will be implemented as a collection of cryptographic algorithms and will be one of the key components for both the security and the main functionality of CryptoFactory. So this layer will provide a complete cryptography toolkit that will be used to protect stored data and secure the communication between connected components and entities in the system. In addition to that, it will support the secure execution layer to assess the trustworthiness of the underlying cloud platforms and on-the-edge devices collecting and transmitting factory data. Now, the crypto layer will be fully integrated with the cloud layer and will secure the communication on top of that. Finally, it will also create a set of modern encryption techniques that will allow us to process encrypted data. These kind of techniques are just, for example, searchable encryption, where we can search over encrypted data, attribute-based encryption, where we can attach policies on encrypted data, and functional encryption, which will allow us to make certain computations on encrypted data. Right, so the anomaly detection layer is an important aspect of smart manufacturing, and if the operation of a machine, let's say, or an asset deviates from the set standards, it may affect the overall operation. To this end, mechanisms that will be dedicated to detect outliers, faults, or anomalies before this actually occurs should be in place in every modern factory, and such mechanisms need to deliver real-time anomaly detection paired with a deep analysis framework over stream data. So this will be used to perform machine and deep learning analysis tasks at scale in order to extract complex behavioral patterns and insights to timely identify evolving threats. So in every modern factory, such a threat detection system should be in place that will be able to analyze, monitor and analyze all the traffic of the network and raise alerts whenever find any suspicious activity. Now, finally, because we are running out of time, we have the analytics layer. So one of the core, let's say, functionalities of CryptoFactory will be to allow authorized manufacturing stakeholders to perform analytics based on factory data. Now, this will be done through a series of statistical functions provided by the data analytics layer. And the use of this layer will be to correlate and analyze data made available by the CryptoFactory platform to generate new insights and knowledge. Now, this layer will offer a wide range of typical statistical operations needed for manufacturing data analytics. Apart from typical statistical functions and simple visualization, this layer will be also capable of performing privacy-preserving analytics, and more precisely, the main novelty of this layer reflects the use of functional encryption in an isolated environment. So CryptoFactory will be using the promising concept of functional encryption to run statistical computations directly on encrypted data, and this is the example that I'm going to give on functional encryption. So let's assume that we have a user, an authorized user, and the cloud that has stored all of our encrypted data. So the user sends a request to the cloud to access some of the data and perform some certain computation, right? So the cloud, what will do is that it will not reveal the actual plain text of the data to the user. Instead of that, it will give this encrypted data to certain components, a component that has the, let's say, magic power, magic ability to run certain computations of certain computations on this encrypted data. For example, imagine that these files are just encrypted numbers, okay, and this function can calculate the average of all these numbers, right? So this functional encryption function, okay, will basically output the result of the function, which means that the average of these numbers, without revealing any of the identical values of the files that were sent by the cloud provider to the functional encryption component. And finally, the result will be sent back to the authorized user that requested this computation in the first place. But the important thing is that keep in mind that this guy will only learn the output of the function without having access to any of the individual stored values, right? So apart from performing standard analytics on the cloud side, in CryptoFactory we envision the generation and the design and the implementation of functional encryption components that will be able to run specific functions directly on encrypted data, thus allowing us to perform privacy preserving analytics. So that's it. Thanks a lot. I know it's a bit strange to see a presentation of a conference like that. I hope next year we will be able to meet and have a proper conference. Now, I was Antonis. Here you can find, you can see my personal address, my personal webpage, as well as my email. Please drop me a message if you need anything, or if you liked, or if you have any the presentation, or if you have any comments or any kind of suggestions for further for future collaboration. Thanks a lot. Bye bye.